The standard deviation is a great tool for helping us understand how spread out a data set is. We know it's around the mean, but we want to know, is it close together or spread out? And the standard deviation will tell us that. But what if we want to know how far an individual point is away from the mean? We can actually use the standard deviation to describe the distance of one single point away from the mean. That is called the z-score, and that's what we're going to talk about here. Now, you could think of a z-score as the number of standard deviations a data point is away from the mean. Remember that we basically talked about the standard deviation as if it is a distance from that mean. So, for example, let's just do a quick example here. We're going to do something finance-wise. Let's say that we have some data with a mean and a standard deviation of $10. Okay. Then I want to know how far away is something if it's only $5 away from the mean. Okay. Standard deviation is $10. This particular item is only $5 away from the mean. Well, $5 is half of 10. 10 is one whole standard deviation, so $5 would be half a standard deviation. That's the idea of a z-score. How many standard deviations are you from the mean? Now take a look at the equation. This looks scary because it's in Greek, right? Forget the Greek. The Greek, remember, just indicates population. You can come over here. The equation is just the same for a sample. I hope that this top half, though, of this fraction looks familiar. Haven't we seen that before? We saw it at the very beginning of this lesson. This is the deviation. This is the distance of one single point from the mean. So in the example I gave earlier, this deviation would be the $5. I am $5 above the mean. Well, if you're $5 above the mean, that's great. But now divide by the size of one standard deviation, which is 10. 5 divided by 10 would give you 1/2. So if you have if you have a deviation of $5 above the mean, that would translate to half a standard deviation above the mean. That's the idea of a z-score. All right, let me actually show this to you in a graph just so that you can see how this might make sense. Since I used this example, let's go to do that. All right. So I said, no, I'm sorry, mean was not 5. Let's give it this another number. Doesn't really matter. 43. Why not? Let's say that the average finances of this finance problem is $43 with a standard deviation of $10. Well, that means that the mean is 43. But one standard deviation above that would be 53. 2 standard deviations above would make it 63. And 3 standard deviations above would be 73. You could also go below the mean. 1 standard deviation below the mean would drop it by 10 down to 33. 2 standard deviations below would be 23. 3 standard deviations below would be 13. All right. So along I come with a particular item, and I'm going to sell it for $48. Okay. $48. Well, hang on. That's the mean is 43, but this value is 48. That's $5 above the mean, just like the example I gave you earlier. Now, if I plot this point and show how far it is above the mean, that looks, well, right in between these two lines. That's half of a standard deviation. Okay, and we already did that calculation that $5 deviation divided by a standard deviation of 10 would give me a z-score of 1/2. Excellent. There we have a great visual of the z-score. Now I could increase the z-score. What if my z-score is 58? Well, 58 would have a deviation of 15 above the mean, right? The distance between 58 and 43, that's a difference of 15. Divide that by my standard deviation of 10. What's 15 divided by 10? 1.5. I am 1.5 standard deviations above the mean. Let's go for another one. Ready? Let's do yeah, we can do 28. Why not? This is actually, we just barely did this problem, but this time 28 is $15 below the mean, right? The difference between 28 and 43 is $15, but it's going to be negative because 28 minus 43 is negative 15. And what's negative 15 divided by 10? It would be negative 1.5. So in this case, I am still 1.5 standard deviations away from the mean, but because the z-score is negative, then I'm going to be on the left side of the mean. Great idea for z-scores. And let me add one more thing here before I wrap up. I wrote down here the z-scores for these different lines. If you are one standard deviation above the mean, in other words, you go from 43 to 53 in this example, you're one standard deviation above, that will give you a z-score of 1. If you're 2 standard deviations above, that gives you a z-score of 2. And so there's a huge benefit to this. Not only do we see how far a single point is from this mean, but we can compare this difference on any other scale. So, for example, let's say that you're selling an item that's sold in different countries, and you want to see how does the price of this item compare with the average prices in stores in your country. Well, the average price is $43 in the United States, but this particular item that you're selling is $28. So you're 1.5 standard deviations below the mean. But what if you want to go to England? The average is not going to be $43. It's going to be something else in pounds. Or if you go to Russia, the currency is different there. If you go to Mexico, the currency is different there. And so it kind of loses its effect if you say, oh, I'm $15 below the mean versus 500 pesos below the mean. I can't really compare them. But if I convert everything to a z-score using this method, then I can say, oh, this item is 1.5 standard deviations below the mean, but in Mexico at this store, it would only be half a standard deviation below the mean. And in England, this item is half a standard deviation above the mean, and it gives us something more that we can compare it to. So because of that, this helps to standardize the data, helps to standardize the units. So we often call this particular situation where we deal with z-scores a standard normal distribution. And the way you get a standard normal distribution, is having a mean of 0 and a mean of 0, standard deviation of 1. Let me throw in axis numbers there. Mean of 0, standard deviation of 1. It gets us to the same scale as our z-scores were over here. Okay? If that last little bit threw you off, don't panic. We'll come back to it later. I'm just showing you that the z-scores shift data from its own individual scale to a standardized scale that everything can use. That's the idea of the z-score.